Yeah. So everyone should have it for all years. So this little icon here, you see what it is. I have to go into the scenes.
Okay, rolling, Kyle.
You're recording?
Where's now? Cool. If someone can be some flower, some kind of skills in order to be awesome. You can hear me? Okay, so I came in on Monday with the start of a call, given nicely and lovingly to me by my youngest kid, and gave 15 hours of class, class, 350 days, which destroyed my voice. So please bear with me, be generous. You can ask all the questions you want, interrupt me, that's fine, I'm okay with that. I'll try to repeat the questions as best as I can, and be understandable as best as I can, but I have what I can give you today. I was mute for the last 24 hours, or almost, trying to be at least able to do something today. Fingers crossed. This is the slides will be made available for you to write to afterwards. This is a part of the plan that you have before you, of where we want to go. There's probably too many slides, but most of them are quick to go through, so we'll see what it gives. I didn't practice for lack of a voice, but we'll see what it gives. I'm going to start with a simple problem, if you don't mind. Something that often happens to me, or to people I work with, that seems innocuous, that's actually quite a thing. Suppose you're writing code, and then you're writing, I would really need, or like to know the maximum value of an int in my language. Because I don't want to remember all those digits, everything. So you go around and you ask the experts around you, and someone says, well, I have this Java language that I really like, and it's a very good language because we have a class for each of the fundamental types that we have. It's an immutable thing, and it has constants and various services, and you can ask for integer with a big I, dot max value, and it's awesome. Really cool. Really cool. Then you ask someone who does a lot of C#, .NET, whatever, and he says, well, it's a cool language. We have these classes, these reference types, and these structs, these value types. And structs have methods and constants and stuff. So they have this max value there. So you can ask an int.max value and you'll get your thing. Really cool. And then you ask someone who does C, says, well, we have a macro called int.max. Why not? Cool. Okay, cool. C. But then you continue working because the world is what it is and doesn't stop with ints. At some point, you're wondering, well, what about short? I never seem to remember if it's 3277 or whatever. So you're asking your Java friend who says, well, remember, it's a beautiful language. We have this immutable class for each of the fundamentals, and we have this short dot max value thing that gives you the maximum value of a short. Awesome. The C# person says almost the same thing. Remember what we told you. You have this short dot max value constant because those types that we have, they're like structs. They have services in the school. And then you ask a C person who says, of course, we have a macro max without the O. And I could tell you why, but I won't. So it's kind of an amusing thing. But again, the world is complicated and we write generic code. And at some point you ask yourself that question. What if I have some type T, hopefully numeric of some kind, and I want to know what the biggest T is? So you ask someone who does Java. It's unclear to me that there's an answer to that, at least in the language. Maybe there is, and I don't know about it. But if there is, I couldn't find it searching on the internet. C# used not to have an answer, but there's one now. It was pointed out by a student. Something called I min max value of T. So if your class implements that, it has to have the max value constant in it. So if you had code before .NET 7, there was no real answer to that. If you have one since, there is one. But if you had classes before that time, you have to change them retroactively. And if you, that's the point. You have to go back and change your code for that to work because interfaces are part of your type, So if we had an interface with a new contract, your old classes didn't implement it, well, you have to recompile. It's just part of the deal. And if you ask the question to C programmer, it probably won't make sense to that person. Yeah. So it's a real problem, really. Not the problem of the max value, the actual problem of if you need a mechanism that your language doesn't provide, it kind of complicates the way you write generic code. You want to express things, sometimes you're kind of stuck. There's no way to say it. But there's no cute way or a nice way of saying it. And if you end up with something that is intrusive as a solution, well, if it's something new and you have the same code, you have refactoring to do. That has costs. Yeah. If you do have a mechanism, well, if it has been there from the start, it's awesome because everyone knows how to do it. It's perfect. If it happens along the way, well, again, refactor, recompile, and everything with the costs involved. I've been on projects where recompiling takes more than a day. Sometimes you can recompile code that's already been shipped somewhere. It is a pain. So it is possible, because .NET has done it, to offer an intrusive solution to that kind of problem. But when you're a user and you need someone else to provide a solution that is intrusive for you in the next version of your library or your language, it's unpleasant. You can make requests, and people are very nice, they tend to oblige, I'm sure. But for your own code evolution, you need to find workarounds, and it's not necessarily the most pleasant thing to do. So being able to write your own non-intrusive solutions can be an important thing. It gives you freedom, gives you a form of independence. However, there's reasons why we do intrusive stuff. I mean, everyone does this. Everyone has had a class hierarchy at some point. Everyone uses interfaces. It's totally fine. It's not a bad thing to do. Lots of people write code like this. I said, it's teachable. People learn that in school. You get new employees, understand what you're doing when you're doing that. The tooling is just very good for this. You type the name of a class or an object, dot or arrow, depending on your language, and poops, that gives you options. So we know how to do this. There's a reason why this exists, and why this is popular, and why this works. People write things like that. These are some of the kinds of animals I have at home. I have quite a few. And it seems like the rabbits are getting angry due to my absence, and I will get bitten tonight, I've been told, when I come home. So you look at this and say, well, maybe I would like to make a container of cute animals at some point. Well, the reflex is to have some kind of base class for most people and saying, well, they're all beasties. Of course, that means that they have something in common, at least in an operative manner. You're going to put something probably virtual up there because it's public inheritance. And say, well, all BCs must conform to this interface in a large sense of the world. And maybe they will try to enthrall you because they're cute and they want cuddles, which is what these kind of animals do. Even the cats, they want cuddles sometimes. They decide when, but still. So they will try to enthrall the humans, which is what these things do, as I said. So this looks like real code, doesn't it? Yeah, it does. And then if you have a zoo there, and there's this, it's a trap thing, with the poor human coming to see the cute beasties, well, that human could be enthralled. That compiles fine, and I think it makes sense to most people. Except for me for the theme of the example. I try to leave links for working code for those who are curious sometimes. I'll leave the slides available. Of course, if you make a small, look at the name of the function. Sometimes you're confused. Make a typo. Of course, your tools will try to avoid those typos for you, but it does that. So you do copy paste. So I called the wrong function there. You say, well, compilers are good to give good diagnostics for that. This one is pretty awesome. I think it was GCC. It's telling me not only did you get the wrong function, but you probably meant this other one. Tooling is cool. So I can understand people saying, this is the way to go. I mean, it guides me towards pleasure, achievement, whatever. It's a nicer messages. I think so. You can make other mistakes. You try to make it's a trap, work on something, maybe something different than humans. Let's see, depends on how BC evolves. And someone confusingly below sends an int there. Well, for the code we have right now, it won't compile. But it's still reasonable error messages. It's telling you, no, your call doesn't work. At that point, it's because, well, you're trying to pass value, and no, it's not an integer, it's a human that's expected there. So good reasons to use those prefixes. When you're being guided, you make mistakes, just as we all do, even if it's just because we're distracted or tired or because there's a cat walking on a keyboard. So yeah, so imposing a base class interface that's proven to be useful over time. And there's many upsides. You know, you can use your derived classes as special case of the base class, so you can express complex IDs through gradual refinement. It's awesome. You can provide contracts. You can say, if you're one of the derived classes, you shall write those functions or properties, which are in fact functions or whatever. And you can go through an abstraction to reach the most derived implementation of something, which is really a lifesaver. And when that came into my life 40 years ago, I was really, really pleased with that. The switch cases it replaced were awful. And as we saw, it gives you some nice error messages. But sometimes in C++, write code like this. And it might not jump to you right away, but this will not fly at all. Because I'm trying to copy strings into ints. And when I do that, maybe I wanted to put something else than string when I was distracted. You know what happens? Totally. And because I'm using lots of cool tools there to do the job for me, well, it will, even if we have better error messages than we used to, it's going to be painful. You know, it's going to look like this. It's 3 pages of error messages just for that. If you want to try it yourselves, feel free. It was like that 2 days ago. It's probably still stable. So but that's okay, because we use like unconstrained templates in this case. So your compiler will generate the code and then look at the results. At some point, we'll try to assign a string to an int. And through the back inserter, which adds a layer of pleasantness in error messages, in copy and maybe layers provided by your own standard library, and you're going to get a lot of error messages. But it's cool, though. It just doesn't make sense. The reason for that is that like boldface thing there, it's just a single line, but we're not checking, so we just generated code and boom, it explodes. Other languages will give you constraints sometimes, and you'll get very clean error messages, but for unconstrained templates, it's still something today. But that's not intrusive. I didn't have to put an interface anywhere in there. It's just working. Well, not. But there are downsides to these intrusive things, though it's not perfect. I want to point out right away, because this is a multi-language conference, so it's quite important. Lots of the following examples will be in C#, because I have familiarity with it. I'm not as much as the architect in the room somewhere, but C# is not a bad language. Just to make it clear, it's a very good language. It's cool, does lots of cool things, but in many cases, it has intrusive solutions to problems which work, but do cause pain sometimes. It's a good poster child, but it's not the only one. It's just the one I'm familiar with, and not there to batch on it. So this, what do you think about this? This is C# code. It's kind of similar to what I had in my other example. I'm trying to copy strings into a list, which is their vector type of integers. And code is, I think, reasonable looking. What do you think? So you remember I had a wall of 3 pages of error messages in my unconstrained templates. In this case, this is what I will get. It's kind of cool. But that's not because the language, that's because the choice that was made to constrain the thing. So it's checking everything. It's, well, you're trying to add this type to a container of that type collection. And well, you're not supposed to do that. Well, okay, fine. You can check it out yourself if you want. That it's pretty much the same kind of code that I add, except for the constraints. Add range would be better, just to show up stuff. If I make it different, I have shorts and ints. Now this in C++ works, no warning, no error, does exactly what I want to do. In C# it does this. So it's not, I had a much better error message for me trying to mistakenly put a string into an int. Now I'm trying to put a short into an int, and I get the same problem. Because we don't reach the point where we realize that it will actually make sense. I'm trying to put a U into a list of T or something. It's the same type. I didn't say it was okay to do that. No. Well, the error message is nice, but the situation is not. Well, maybe it is, depending on your mindset, but it bugs me. Making sense so far? I don't know, the noise is probably not good, but still. So I would have liked that code to work. It's kind of a sensible piece of code, cutting shorts into ints. In my life, it kind of works normally. So, but I'm kind of glad of the earlier message that I had before. So it's not all ups and all downs. Let's try something else. So addition of integers. This is so cool. On a wrapper class of some sort, because for ints, it probably works already in the language. Again, this is not a C# bashing thing because we have problems in all languages. But this code compiles. I don't know if you like it. The first call to plus there is on ints, obviously. The second one is on ints, with the big I, because I overloaded the way C# does it with static public operator functions. That thing and shit a new integer based on the values. This is working code. It compiles without a hitch. It's neat. It's cool. It's close to what I would do in C++, with different semantics maybe. Now let's try to do this in a generic function, an add function there. So that add thing looks good to me, but this won't compile. But it's okay in the mindset of that language. It's not a bad thing, you know. But I have operator plus on int. I have operator plus on that fundamental int of sorts. But that add thing doesn't know that this thing is addable, so it's going to complain to me, rightfully in that mindset, saying you cannot do that. You didn't say it was possible on add to add two objects of type T. So yeah, you cannot do that. This is on the add function. That bugs me as a C++ programmer, where it would just fly. Of course, they now have an interface for that. It's called addition operators, TTT. Well, the syntax in C# is first argument, second argument, return value. So it's add two ints, get an int. That's pretty much the point. So looking at this, if I implement addition operators int on my int class, and the int fundamental type does it too, because remember that language has no real fundamental types, it has value types and classes, so they can have interfaces on both sides and everything. This is cool. It's new stuff, newish in a few years, but still, this will make this code work. I think it was pointed out to me by one of my students. This is not unpleasant. It's not necessarily a bad thing to say, well, I kind of required that thing to implement plus because it's checking at an earlier point in the code generation process than we would in C++. Making sense still? Okay, so not all good, not all bad. So we had that short to int conversion earlier, where I was trying to put shorts into ints with a copy function. I won't go modify the struct types of the .NET framework to make that work. Short is there. So I'm going to write a wrapper class of my own. Just wraps a short. Okay? So short with a big S, we see the class below. So I put arbitrary values there. I have a list of int. I'm trying to copy my short S into ints. And I'm going to put an interface of my own called iConvertible to TU. So the intent I have is I want to claim that the T is convertible to U and put the code in the interface to force that. Make sense? Cool. So the code is on the next slide. So I tried to put it that way. The operators that perform conversions are static member functions of public classes like this in C#. It's missing that public thing. So I tried, this interface is public anyway. So I'm trying to impose that constraint saying, well, any type that implements iConvertible to TU shall have to convert an iConvertible to from that interface to type U. And I try to express that with operator int below because I'm convertible to int my code. So does that seem reasonable to you? Kind of? Yeah. To me too, it doesn't work. But then it's interesting though, because the error message is telling me, you are not allowed to convert to or from an interface. Okay, I did not expect that. But if that's the rule, that's the rule. So it means I wasn't being idiomatic. That's important. If you're writing Go code, writing Go, and you try to use Go idioms. You're doing Java code, you're trying to be in the Java mindset. If you're doing C++, you're trying to do C, it's going to look bad. And you all know that, I think. That's on me in this case. I tried to do something that seemed okay to me, but if that's not the way to do things in that language, I'm going to work it somewhere else. Yeah. It's not bad. It's just reality of things. So I tried to keep it that way again, but I put a to member function in the interface that returns a u given a t. Why not? So it's not a conversion through an operator that will give me interface, it's something else. And I put it that way with that to function there. Yeah, fine, that works. So I wasn't far. That it's just a twist, understanding how the language works. I don't know why it's restricted and not allowed being said, but maybe I'll get a chance to ask if I still have some voice left at the end of the day. Making sense? If you're not used to that little arrow thing, it means return. I love it. This is one of the things I would like to bring to C++. But it won't fly anyway. Okay, so it works. But now you might be wondering, what if I want to be able to convert short to something else than an int? Like with operators, it kind of makes sense to me, but now I do have a single function too. And as you probably know, when you're overloading functions, you're looking at function names, arguments, types, and number, but not return values. So if I write this, it's going to complain to me and rightfully so, saying, you already have one, you idiot, in like compiler words. You can see that? Cool. But there's a way to make it work, though. You have to write it this way. You have to spell out the name of the interface first. And when you're doing this in that language, as long as you pass through the given interface at the proper function. So it's not ambiguous anymore. You're just going to call it from short itself. So it's intrusive. It's workable if you work on it a bit, as long as you understand the idioms of the language. We can make it work. So this is okay. Still okay? But it's a lot of effort. I would have liked to put the short into an int and have to go through some loops to make it work, some hoops. Okay. Of course, if you don't require interfaces to check your types up front, it's easy code. This works out of the box. As we could see, though, it's because there's no error. If there's an error, it could get messy. But this is very nice. It's clean, it works. It's efficient. Questions? Cool. Okay. So it's an IRR situation. We can already see that we get probably good tooling with the intrusive stuff. We've got decades of experience with that. With templates, we still have weird error messages sometimes. And there's good and bad to be said, both something that forces you to refactor your code and something you can build from without, let's put it this way. I just want to say a few words about granularity of interfaces, because that's kind of a weird thing too. I wrote small interfaces there, like a to function. I tried to put one with a single operator. If you did that to the extreme, you will end up with lots of interfaces with a single function in the contract. That can get ugly. So I was looking at the iNumber interface used by numbers today in C# because that's the way they went. I wanted to see how they did it. There was this I-addable operators and stuff. It looks like this. That's a mouthful. If you remove those system.numerics everywhere because it's a namespace, it's still that. I don't know if that's the right granularity where for someone to want to work, but I can understand though. If you're saying, well, someone who implements plus might not want to implement minus, well, you want to put them in different interfaces, I guess. So there's not, it's still quite a big thing. And even with this, you might be saying, well, look, the interfaces are there. Just use them, which is cool. But it's still difficult. Because I tried to do this, it's a long standing example online. So you have a pair of two things. And I wanted a pair of two things to be addable. So saying, well, if I have T and U, I want to be able to add the T's and get a T. And I want to be able to add the U's and get a U, which is what I did in my operator plus that. Okay. So, and that works. That's workable code, no problem. The out there works fine. But that's not mixed type, it's the same thing. If I want to add an add there with an int and an int with a big I would like to do kind of mixed type computation. This is probably not what those interfaces were thought of for. In fact, to be honest, it could be 3 different types. But given the way the language is structured, I didn't find an easy way to say, I have these two types. What do I expect as return type when I add them together? Maybe there's a way. Maybe there's a way. Just didn't find it out. But as is, it won't fly. It's not the right signature because I have two different types. In C++, I would look for a common type of the addition or something like that, or just use auto. In this case, I cannot do this. So I would have to find a way to, if I give you T and I give you U and I do an add on this, what type do I expect? And if there's a way to do that, I don't know what it is. It kind of ends up to the problem of those question marks there. So even if you have the interfaces, it's not enough. It can take more to get to where you want to go when trying to express something in a generic way at the very least. It's not a simple problem, just doing addition, you know? Still okay? Cool. There's other upsides too. To be honest, I'm not going to be exhaustive, but if you're just for the traditional stuff, intrusive stuff, one of the self-evident things is you can put different objects of various classes with a common base together somewhere. The V there is an unknowning thing. It owns pointers to existing objects, but they have a common base, so it can be a vector of VC. This is fine. This works. If you want them to be owning, can be unique pointers to imagine fine. This works fine. If I didn't have a common base, this kind of code would require some other tricks like variant or something like that. There's also if you're writing code in dynamic libraries, you tend to expose your code through interfaces to have something very opaque, such that client code is not affected when you change the code underneath the covers. That's a totally fine implication of this thing. You want to be able to change your code without affecting the rest of the world and recompiling everyone's interfaces. Sometimes there's just a way to go. That's totally okay. Or something like this. So to the left, I have my interface of sorts, BST. To the right, I have two kinds of BSTs, and my factory function decides that it returns cats. Cool. Anyway, it's something the client code doesn't know in practice. It knows just it's a BST, and I can do BST things with it. And if I change my mind and decide that it's guinea pig, squeeze, it's going to be guinea pig. Anyway, when I call the code, it's going to look like this. I don't know where it is. I can probably find out something if I work on it, but I don't want to know. Or I'm working according to the interface. So it's design trade-offs. I won't spend too much time on this, but I know that in some of the communities where I give classes, they're big fans of intrusive shared pointers. The ones we have in the library are not intrusive, they're extrusive, they're written around the objects. There are upsides. There's some really out of size to the intrusive approach. It's reasonable. Intrusive lists are also popular in some circles where the actual nodes know of their neighbors and you give them helpers to write their code properly. Some people swear that this is the way to go, and I believe them for their use cases. It's not what the library of the standard library C++ does these days, but it could be added. There's also this thing that Klaus likes quite a bit, and me too, where we're kind of in a hybrid situation between intrusive and extrusive in a sense, because you're writing your base class like this as being informed of the derived class it will be held as the front entity for. And when you call grow, it's saying, I'm going to call the grow that the thing that I've been informed exists, and it's probably the derived class of mine if we respect the design in this case. So there's no single base class in this case. There's as many as there are D types. And then you can have a guinea pig that injects its name into its base class, same as cat. But you're growling through a BC of some kind, and it's doing a cast. I think that's kind of nice. And it looks like the normal interface pattern, but you don't have some of the costs. You're not paying for the indirect call because the static cast leads you to the direct proper for a class and function and everything. It kind of makes nice call. So it's intrusive, but by design, I'd say something like that. Yeah. So there are alternatives to that. And I lost track of time because I didn't start my timer. So if we don't want to put that, what do we do? This is obviously not exhaustive in any sense. It's what came to my mind when I started thinking about this. As we all know, the straight standard templates are like that. They're not imposing anything on you. You don't even check what you're doing until the very last moment. So you get Very nice working code if you're writing your code right and horrendous error messages if you mess up. So it's marvelous when it works. It's tremendously efficient. You sometimes have readable errors and sometimes you have surprises. You can really do a lot of stuff. They're like building blocks. There's the simplest things. And the subject is way too huge for it. If you've never heard that, there's a wonderful lightning talk by Michael Case called The Standard Slam, where he quotes parts of the standard with the word template in it. It's quite a nice, pour yourself a glass of wine, take 5 minutes, you'll love that. Standard Slam, it's awesome. Most generic languages, generic programming in most of the languages I know doesn't work like that. You check stuff early on like C# does, and they try to give you better messages, they put constraints. In Java, you can say, that type could be anything as long as it's a subclass of this or a superclass of that. So it's very much ensconced in the hierarchy mindset. Something like this. This is C++ code, no constraints. It's a solution for a mixed type add problem. Simple, self-evident. Of course, the last one below will not compile, but you only know once the code has been generated, and you'll get whatever message comes out of that thing. Trying to add an int to a string, whatever that is. It's probably not that bad in this case. There's not too many layers. What saves us in this case is the return type. It makes everything easier. You might not remember the times before auto, but auto return types have only been there for 12 years. Before that, we could work it out through a wall of templates. But between C++ 11 and 14, we could make it work otherwise. We could use auto at first, but we had to push the return type at the right end of the signature of a function. And then using declaration type to express, this is the type I want, based on the type of the arguments, or their names in this case. The reason why is at the right end there is because the code is read from left to right. So you need to know what A and B are. And if you're saying, oh, this is terrible, you're repeating the code of your return statement in the function, and your signature is longer than the code. Yeah. Indeed, you're absolutely right. But for a while, before we knew what to do with a function that has an auto return type, but many return statements of potentially different types in its body, we went for the safe approach. But now auto, everyone I think is comfortable with that. Some people don't like auto, but it does solve this problem. Making sense? Cool. This is still useful sometimes. You want to say, I'm going to return a reference to something to the user's value by default. One thing we use quite a bit in the standard library, I use quite a bit myself in the classes. I work with game programmers quite a bit, so they're very much performance conscious. We have this thing called traits. From a non-intrusive perspective, this is really cool because they let you infer information about your types, your functions, without changing anything. You're just looking at what they look like. You're reasoning at compile time based on things you know, their sizes, the types of the arguments, their alignment, the possibility to perform a conversion between two things, all sorts of cool stuff. When I try to express to students what I mean by traits, because they look at weird, think about it. You're entering a master's degree, you've done Java for 6 years, and someone starts coding with empty classes and templates that generate no code. You're very confused. This is the reality. And then they get with it because they're brilliant, of course, at some point. So I try to tell them it's like documentation about your types, but outside of the types. It's outside. So the types are not affected by this. You're reasoning from the boundaries. So the problem, the initial problem stated was, I want to know the maximum value of some type T. What is it? You know, oh, int doesn't have member functions in C++. There's a constant, but it's not attached to int itself in any way, not like Java would do it. So you might first say, well, there are types that exist for which this question doesn't make sense to me. Like there's no maximum value for a string in my mind. So we can say, in general, that thing shouldn't compile because I wouldn't know what to say. And then for some types, though, you might have an answer because for int, there is a constant. The question is, how do I ask the question based on the type? And it could look kind of like this. You could say, in general, for the first case, template class struct max of. In general, for some type, there exists something called max of. It's a class. Structs are classes in C++. The difference is whether the members are public or private by default. There's other things. So max of exists, but I will not tell you what it is. It's an incomplete type. So you cannot use it as such for string. You will get an incomplete type message unless you have the very strange idea of expressing what it means for a string, in which case it's on you, not on me, because it's extensible. And then you hit the point where you say, well, for an int, I know what the answer is. And then you provide a nice constant that maps to a constant that already exists, because why reinvent the wheel? You know? And repeat that thing for the types you know about. So if you're looking at the standard library for the traits that kind of do this, well, the basic types are already there. But that doesn't stop you from extending the system with your own numeric classes that you invent yourself. So if you have a percentage or something, maybe the upper bound is 100, I don't know. So yeah, this is what you get. You get the general case first. This gives you the general shape and form of the thing. It's a struct on a type, in this case. Could be on a value. And then you have the special case that says, and then for that specific type, here's what it looks like. So you get total freedom. You can even put different contents in between, but at your just know that people are going to be trying to use that at some point, and if it don't make sense, they won't use it. So this is where the mapping happens. The first template angle brackets saying, in this case, I have nothing special to tell you, just that keep on reading, you're going to find what the type is. And there's other examples for other types of syntax. This is cool. I can infer the type of any type that I'm worried about without touching the types. I'm adding in-code documentation that's only compile time on top of it. Awesome. Fair enough? Okay. We have something in the standard library that does this. It's called numeric limits, but it's an old thing. So it has lots and lots of information. Something about the epsilon of your type, the min, the max. Do you have a quiet man? How many digits do you need to represent the thing, if it's signed or unsigned? So it's not the way we do things these days, but it exists and it's usable. There's efforts ongoing to bring it, maybe modernize it in terms of style to make it more granular. Because with traits, it tends to work well when we're configurator interfaces that you have to implement, and you can have to write quite a bit. Traits are something you use. So you don't have to say, I implement those things. It's on you. So you can be very granular in the way you say things. So we normally tend to focalize on if it represents a type, it's called type. And if it represents a value, it's called value. And there's a few things that are a bit more modern than that. So for a few examples, a question that you could ask, it's very simple to answer and easy to understand, I think is, I have this type in my code. I would like to loop on it, so I would like to make some kind of counter. Is that thing const? Because if it's const, I want to do plus on it. It's not going to work. I'm going to make a copy or something. So your general case would be, well, in most cases, like int, it's not const. String, not const. Float, not const. And then you say, there are cases where it's const, though. These, the cases where you have some type T and you meet the pattern const T. Oh, these are consts. Okay, and we could wrap that up with other stuff. That's the basic idea. So there's a single pattern. It's for a type. We have a general answer. In this case, it's no. And then, for some patterns, the answer is yes, and here's how to distinguish them. On the compiler, it says const int. We'll have two options that work, but the one below is more specialized. It's going to say, aha, this is the one I want. It's more precise. Making sense? That gives you a constant, a parametric constant. It's kind of cool. But this is for a value. So if you're wondering then, if I want to remove that const thing for a type. So if I have int, I want to keep int. But if I have const int, I just want int. I don't want that const thing. I don't want to make a variable. I want to limit it. You can say, well, in general, given some type T, the type of that thing without const is empty. But should I face something that says, it's a const T? Well, I'm just not taking the const, keeping that T thing. I'm fine. I had constant, it's int I want. Perfect. Still making sense? It's just compile time reasoning, but it's extrusive. I didn't change any existing type to get there. Just reasoning based on what I'm given. That's it. I'm adding stuff. I have two types. Are they the same? This is actually kind of useful because you're writing code, you might have to do some conversion, but then if you have the same type in and out, you just return the thing and do nothing. This is beautiful. The less work you do, the better, You're saying, well, in general, I have two types, T and U. They're not the same. But if it happens that a pattern is T and T, what can I say? They're the same. Let's go on with it. It's more subtle than that. That's a general idea. Still making sense? So non-intrusive, nothing affected. You can add stuff, doesn't impact anyone. So they're all non-intrusive. They provide information on types, infer facts, types and values. I don't have any examples with values, but you can do that. And if you're adding a trait, unless you have a name conflict with something that's already there, it's on you. You can even extend the system and add specializations for your own types to what's already there. It's an open set. It's not like classes. So we have this thing called type traits in standard library. It's filled with these. Lots of them are easy to write. Some of them are tricky to write. And some of them are just not writable in a portable way by users like you and I. You need the eyes and ears of the standard library to do it. It's polymorphic. Can you say, by looking at a type, if it has achieved at least one virtual member function? Well, not portably. But your compiler knows because it has looked at the source code. It can tell you. Okay? Cool. This is useful too. Okay. So writing generic code for mixed type, we saw it earlier. We had that auto thing. It's a lifesaver. So if you're trying to do mixed type comparisons in an unintrusive way, you kind of like those type deduction things. They can give you the answers that you would otherwise have to work very hard to get to. For a compiler in general, it's easy to do. So we have auto, we have declaration type of an expression, declaration type of auto, you can add const and ref if you feel like it. So you get a lot of freedom and leeway to express what you want to say with precision in an unintrusive way. C# has something called var to do that, but you cannot, as far as I know, use it in a return type of a function. Maybe someday. It doesn't mean the language is bad, just that it's not a solution for this problem, as far as I know at least. So if I'm trying to write something like this, I want to know if it's valid. I'm talking about validation. Is it valid to do A plus B for some type T? It's a reasonable question. In this case, I kind of have my answer by default. I mean, if you're trying to use my function in C# with this, and you don't support the plus operator in an idiomatic manner, it won't compile. It doesn't tell you if yes or no you can do it. It just refuses to do it if you cannot. It's okay. It's not really an answer to my question, but it's okay. If I just want to know, is it possible? Because maybe I have other solutions. If I don't have that plus operator, maybe I can do it through some other means. So I would like to ask myself, is it possible to do that? The things that I like about C++ is, and some people don't like it because too many options, is that we can actually solve that problem through just programming techniques. Mr. Walter Brown has shown that to us in 2014, with the thing we standardized in 2017. He said, I have found this nice mechanism that lets you validate any expression based on its type. And if you can express something and the type makes sense, you're in. It's a general verification or validation mechanism at compile time. We call that void T. And if you look at CVP reference, void T is a single line thing. It's very, very simple. But it's awkward to look at the event because your mind doesn't want to process it. It's not difficult to use. So this is how it works. I'm going to highlight some things. So the question I'm asking is, can I do plus on type T? Whatever that thing returns, I'm not taking the return type in this case. So I want to add two T's together. I'm calling that is addable. So is addable of int will say yes. If I'm doing some empty class like below X, I didn't write operator plus, and say no. That's it. Isable string will work. So there's two steps there. There's a general case that you see above. I'm saying in most cases, addable, the answer is no. So this is by default. I'm presuming, assuming that it's not editable by default. Probably reasonable in this case. The signature is just something to remember, but the point is it's on a type, and there's some other type that defaults to void, just such that doesn't get in the way. It's a two-type thing. False type is a threat that represents the value false. It's a struct with a value that's false. It's very useful too. If you're wondering why this is useful, if you have done some C programming in the past, you probably know that 3 is true, isn't it? If you do if 3, it's going to say yes. As ugly as it is, I know. And if you do 3 equal true, it's going to say false, of course, because true has value 1, which is confusing as hell. So there's only one true type, only one false type. It's much easier. So this is my general case. General case, no. And this is where the genius of Walter shines. I have T, and then I have void T of some expression that could be valid or not. The point of void T being there is to make the thing perhaps invalid properly. And I have something else finited away, that means get rid of it. So I'm saying if I can form some T and some other T and add them together, and that makes sense, it's addable. I'm not looking at the return type again. So this might look weird to you because there's this declaration val thing there. What the hell is that? This is cool. It's a function that doesn't exist. You can call it. There's nobody. The entire code is template class T, QRF, declaration val, run, semicolon. You can call it. It's not there. But there's a signature. If you implement that thing, you're very bad. So you can use it, but only in what we call unevaluated contexts. When we're compiling the code, not when we're running it. There's nobody. Saying, if I had a T and if I had another T, this is what it means. And I add them together, I check the type, does it make sense? I don't even know what it is. Just does it make sense? And if it does, well, it's editable. It's so cool that you can write something like this without special language support, just out of the box. It's just weird. And you can check at compile time that int can be added, x cannot. When Walter showed that to the group, I was in the room. We didn't know each other back then. He had a standing ovation because we used to have separate solutions for many similar problems. And he just gave to everyone before concepts, which will return, a general solution to a problem we're solving through peaceful means. Really cool stuff. So yeah, this thing is just a function that says, what if I had something? And if you want to do multi-type thing, you have a T and a U, like my case in C# with the small int and the uppercase int. And I want to add them together, does it work? Well, you're saying class, we have two types in this case, T, U. In general, no, but if I have T and U, whatever the types is, and I'm trying to form an add with some T and some U, again, whatever it is, whatever word that is. If that makes sense, we're okay. And I can check if I can add an int and short. And it's going to tell me, yes, of course you can. I never touch those types. It's not intrusive. I reason based on what is there. And if I'm looking at, can I add an x and an int? I clearly no, because int doesn't know about x, and x just empty class. Yeah, this is cool. I can add stuff because I need it. I don't have to change anything. So it really lives on well when you're refactoring your code. Okay. That's a trick, though. That's a trick developed by very intelligent programmers to fix a long-standing problem. Now we have a language-based solution to this. It's called Concept. It's really nice, too. It's actually a language feature. It's one of the beautiful ones, I think. Some people will tell you it's imperfect. Totally true. There are compromises made in the design. The original form that we had in 2011 was probably more powerful than what we have today, but what we have today works and it's cool. So supposing that you could do this with an interface, but you're trying to say, is my type incrementable? What does it mean to be incrementable? So if you had a language based on interfaces for those things, you could say, well, there's an I incrementable interface of T, and you're forcing the implementation of operator plus plus on the proper form, and you'd be okay. And that's cool if it exists. If it doesn't exist, it's refactoring stuff for you. If you want to figure that out from existing code, it's a different beast. But with C++, you can do that. You say, well, for some type T, if I can do plus plus on a T object, prefix or suffix, this is a syntactic constraint. Fine, it's incrementable to my eyes. I can do more, we'll get back to that. So that requires thing says if the code in there makes sense, if it compiles, your answer is yes. So we're checking the values. Instead of function, you cannot call it. It's saying, given some T named R is probably a bad name in this case, it should be obj. But you can do these things with arg, you're done. T is incrementable with respect to what you're trying to express. That this is your intent, your ID. It's probably too granular for concepts. Concepts that feel less granular than that. We found that out in practice. But this is a slide, so I'm trying to keep things simple. Making sense? Okay. So it's kind of answering it. It's giving an answer to a long-standing question. Does this code compile or would it compile? I've been looking for that for a long, long while, and then we have it in language. You can write concepts in different ways. You know? If you're saying, for me, things that are small are cool because I want to put them in registers and or something like that. And I have in my mind that if it's the size of an int or less, it's probably going to fit. It's not true that an int is the size of a register, but it often happens to me. So I'm saying, if it's smallish, I'm going to be happy. So smallish says the size corresponds to my need, whatever that is. And then I said, well, in some cases, I want smallish integrals. So, well, I have a smallish integral if it's smallish. And if it's integral, because we have an integral concept that works for ints, shorts, but not floats or strings. And then you can write functions based on that. I can have a function that takes a smallish integral. It's going to work with an int, but probably not with an unsigned long or a double. You're coding on families of types, not just on types, in a reasonable manner. Ooh, okay. I didn't have to change anything. I'm just expressing my constraints in an extrusive rather than in an intrusive manner. This, I couldn't do it like this. This really looks like the where clauses in C#, which is a good thing because it brings similar values. It brings you upfront good error messages. So I'm saying that function will work if T is addable. So I'm requiring that the concept is satisfied. I can do a plus to objects of type T. Whatever the type is, I didn't check the return type of that type. Could be float. Okay. So f of 3 will work, but not f of x. So you see, we get for this function a requirement on the function, but we didn't have to change the types in which it operates. I'm looking from the outside. Can I write this expression on that type? If I can, yes. Cool. So we get lots of benefits, and maybe not the downsides of the interface. I can do it this way. If I only have one constraint that many, I have to put if I have many constraints, I could put ands and ors. If I have only one, it's the type system. So I can say, well, it's some addable T. So when you're writing class or type name T, it's any T. But now I'm saying, no, it has to be an addable T. This looks good to me. Again, int is addable, but never had to say it. It's inferred. And of course, if you really want to put something and you don't even want to write temp protocol to look normal-ish, you can use concept as an adjective. So here, auto means anything, but then you look at the adjective saying anything, but it has to be addable. I didn't put a variable name there, but I could have just, I'm not using it in the function. So this, again, will work with an int and x. So we can construct something that looks very, very similar to the things we like about, I had C# earlier, but there are other languages like that, where clauses, constraints, things that give you better messages up front, but we don't have to change the code that exists with that. Yeah. Let's pass this. If you want to add semantics to it, because earlier we had addable TTP, so there's something like that, edge operators. I want two T's to give a T as a result type. In this case, we're adding some constraints too. I'm saying, well, that arg thing, when I do plus plus as a prefix thing, I want the result to be a T-ref. And I want if I do plus plus as a suffix thing, I want the result to be convertible to T. Because that's the semantics I expect from those operators. Adding meaning on top of the syntax. Same as convertible to, there are two type concepts. They kind of look like this. Same as TU, probably maps the trait is same. So the first type is what you see between the braces to the left. And the second type is what you see on the right hand of the arrow thing there. So the constraint is expressed as a two-type thing and maps this. It's kind of neat. It's very readable and everything. Again, non-intrusive from beginning to end. And you can overload this and that. You can have a following function there that says, if it's incrementable, I'm going to give you the next one. Otherwise, I'm just going to leave it as is. And you call this thing it. Cool? Cool. Yeah. This is what I wanted to get to, you know? I know that if something like smallish of short is true, I can pass short to a function, expect something that is smallish. In short, there's a typo. Short didn't have to change for it. I didn't have to change it. Returning to more down-to-earth things, with good size about C# this time, when you have a set of functions that touch your private members, you want them to be probably part of your class because you want control over things. When you can build abstractions around without touching the private members, it's kind of cool to be able to add them afterwards. So they have this cool thing called extension methods in the language. Time flies, but I'm going to get there. So I've written this algorithm there for NDC Toronto, and checking if all members of all elements of the sequence respect a predicate. We have something like that in the algorithms that are of C++ too. Neat code, cool, clean. If I call this, it's a function. So I pass the collection, the predicate, as arguments. It works and it's fine. If I put this on the first argument there, it's telling the compiler, make it look like it's a member function of that first thing. It's the same function. And then it appears as a member function of all the enumerables of the language, including the raw arrays, raw-ish. It's because in the sense I'm calling it an array, but array implements the interface in question. So this is cool. As long as I'm working from the public interface of the class, I can refine and add stuff to it. This is what their LINQ library is based on, and it's a beautiful thing. You can do really cool stuff with this. And we can do similar things in our code too in C++ when we want to, because we can, let's say, enrich the IO streams interface. I want to add a point to the console there. The console doesn't know about my point class, but I can tell it, you know, when you want to write the point, this is how you do it. Normally, it would be a member function of the first argument. I'm writing it as a free function that only uses the public members, and it just adds to the interface of OStream and completing it for the types I have added to it. It's one cool way of doing things. We're almost done. And what's the last thing I want to show is that sometimes you have things that kind of look the same, but aren't grouped together through a base class. You're saying, how could I put them together in a container or something like that? You use a variant, of course. One way of doing this is to say, well, I'm going to rewrite my code and be intrusive. I'm going to add an interface with a virtual member function. I'm going to override it in the derived classes and just map to the function I want to call. And it's going to work, and indeed, it's going to work. But I had to change things. I had to change my class A. I can make it differently. I can add the interface, make some kind of wrapper that wraps around my class, and then use the wrapper instead, because my class doesn't change. I can do external changes to my code without affecting it. Yeah, less nasty. But in this case, though, there's an added overhead bit still. Or I can, if I prefer to use actual objects in my code, wrap it inside. So say my callable thing has some kind of interface underneath, a wrapper of T inside that owns a T that will indeed call the thing when I'm ready. Hold the pointer underneath, and when I have a vector of objects instead of a vector of interfaces, the class doesn't change, but it's usable as objects now, and there's no lifetime issue in playing with objects. So we can do that without pointers, and it's totally doable as long as you put money in the right place. So we're almost done. So when I send the proposal for this, I said, well, our toolbox, sometimes we go to the things we know, you know? My students, when I get them, they write things that they know about. So they go to the patterns they know, they go to the tools they know, and trying to open up the box a bit. So, but it's normal to go for the things you know. You have a problem to solve, you don't have that much time, so you use a tool set with which you're comfortable, and it thinks the way you think. That's really fine. And there's a reason for that. When your stuff works, it works probably well enough. If it's well enough, it's okay. You don't have to optimize stuff. You don't need to. And you can tell others what you did. They will understand. They're used to it, which there's a lot to be said for that. So your traditional approaches are probably like that. I'm gonna add an interface, a base class there, define a virtual member function, something like that. It can be okay. It can be completely okay. But sometimes you cannot. Sometimes you don't control the code. You don't control the types on which you're working. Sometimes you just cannot recompile. It's not an option. It's already something. So you're able sometimes to do the things differently without changing the code, working around, adding wrappers that don't cost you anything, decorators like in Klaus's talk yesterday. You can do many things that are cool with this without altering what has already been done, which opens up new avenues for problem solving, which helps you. In the ideally, if it does that in runtime costs. So, just to close things up, I was talking with a friend earlier before I talked, who said, this is a weird conference. Some people are very much into coding and the fun of coding. Some people are very much into AI and vibe. I hope you have fun coding. I know I do. I wish you a very nice day.